Welcome today. The topic of quadratic expression and equation. Quadratic expression and equations. We are going to look at the following: expansion of expressions, and we have already seen how to remove brackets, in an expression, how to remove of brackets in expression, perhaps of the form p bracket x plus y. To remove the bracket, we expand. This will be p times x. We get px plus p times y. We get py. So this is the expanded form of this expression. And also we say that the same idea can also be used to work out with expression like x plus 1 into bracket multiplied by x plus 3 into bracket. The same idea can also be used since we have this expression. So the value, that is the element in the first bracket, the first element in the first bracket we multiply by what is in the second bracket. So in this case we have x, that will be x multiplied by what is in the second bracket, which is x plus 3. Then from there we have the value, the second element in the first bracket, that is plus 1. Then we multiply by what is in the second bracket. So in this case, as we expand, we shall end up getting, this will be x squared plus x times 3, we get plus 3x, then plus 1 times x, this will be plus x, and then plus 1 times 3 will be plus 3. We simplify by collecting the like terms, adding the like terms, so we get x squared plus 4x plus 3, and that is the expanded form of this expression. So we refer this to as quadratic expression. So this value is a quadratic expression. Also, we can try another example. X plus 5 multiplied by 3x plus 1. Also in the expanded form, this will be x multiplied by what is in the second bracket. Whatever we have in the second bracket is 3x plus 1 again. So plus 5. That's the second element in the first bracket. We multiply by what is in the second bracket, 3x plus 1. So we shall end up getting, so if we multiply x times 3x, we get 3x squared, then x times 1, we get plus x, then plus 5 times 3x, that is 15x, then 5 plus times 1, we get 5. So simplifying by adding the like terms, so we get 3x squared plus 16x, then plus 5, and this is the expanded form of this expression. So this is the expanded form of the expression. We can also have a values that is in fraction form. So take an example. Expand 1 over 4 minus 1 over x. To bracket we square. So the same criteria can be used to expand. So this can also be written as, that is 1 over 4 minus 1 over x. Since it is squared, we multiply it by itself, times 1 over 4 minus 1 over x. Then from there we can expand. So if we expand, we have a quarter, that is the first element in the first bracket, multiply by the second element, that is whatever is in the second bracket, then minus 1 over x, multiply by what is in the second bracket. Then from there we multiply. So as we multiply a quarter times a quarter, that will be 1 over 16 minus a quarter times 1 over x, that will be 1 over 4x. Then minus 1 over x times a quarter, that is minus 1 over 4x. Then minus 1 over x times minus 1 over x, that is plus 1 over x squared. So in the simplified form, shall get 1 over 16 minus a quarter, that will be a half. So 1 over 2x, then plus 1 over x squared. So that is a simplified form, the expanded form of this expression. So we can try one more example. Expand, we expand and simplify. So we have 4 minus 2x into bracket, multiply by 1 over 2 minus x into bracket. So in this case, so we have the first element in the first bracket, that is 4. Then we multiply by what is in the second bracket, that is 1 over 2 minus x. We multiply by this value. Then from there we have minus 2x. So minus 2x. Again we multiply by what is in the second bracket, a half minus x. Then from there we now multiply 4 times a half. So that will be 4 times a half. So we have 4 times a half. Then we have then minus 4 times 4x, that is 4, get that value. Then from there minus, we have 2x times a half, then minus 2x multiplied by minus x. So if we work it out, by 2 1 by 2 2, so that will be 2, then minus 4x, then minus by 2 1 by 2 1 by 2 1, so minus x, then plus 2x squared. As we simplify, we shall get 2, it will be minus 5x, then plus 2x squared. And that is a simplified form, the expansion and the simplified form. Something else that we are going to look at is quadratic identities. Quadratic identities. And in quadratic identities, it is very, very important from what we have just learned in the previous expansion. of the expressions. So take an example, x plus 1 squared. In the expanded form, this will be the same as x plus 1 multiplied by x plus 1, which will be the same as x multiplied by what is in the second bracket, then plus 1 multiplied by what is in the second bracket. So we end up getting x squared plus x plus 1, which is x squared plus 2x plus 1. Also the same idea, can use x minus 1 squared, which will also be the same as is x minus 1 multiplied by x minus 1, which will be x multiplied by what is in the second bracket minus 1 multiplied by what is in the second bracket, which is x minus 1. So if we open the bracket, we get x squared minus x plus 1, which we end up getting x squared minus 2x plus 1. And finally, we can have the other one, which is x minus 1 multiplied by x plus 1. So in the expanded form, this will be x multiplied by x plus 1 minus 1 multiplied by x plus 1. So we end up getting x squared plus x minus 1. So which is the same as x squared plus x minus x, that is 0. So we end up getting x squared minus 1. And this is actually referred to as difference between two squares. That is difference between two squares. Therefore, from what now we have, means that x plus 1 squared, in the expanded form it is x squared plus 2x plus 1. The same case applies to x minus 1 squared. We end up getting x squared minus 2x plus 1. The other one is x minus 1 multiplied by x plus 1. We end up getting x squared minus 1. And for this, we can come up with a conclusion of getting quadratic identities. In general, we have a plus b. These are two elements. We square them, so it simply means that if x is a, then we get a squared, and the other one is 2x. That means plus, we have 2, and there is also 1 there, so 2x, that will be 2ab. Then plus, simply this is 1, so this 1 squared, that will be b squared. Therefore the other one, a minus b squared, in the expanded form we shall get a squared, but now in this case it is minus 2ab, then plus b squared. And finally the third quadratic identity is a minus b multiplied by a plus b. We shall end up getting difference between 2 squared, that is a squared minus b squared, and this is referred to as difference between 2 squared. And we say that the three quadratic identities are very useful in expansion and also in factorization of quadratic expressions. Then from there, now I want us to apply quadratic identities in the expansion of the following expression. So we are going to use quadratic identities to expand. So we can have the first example. So we want to expand x plus 5 squared. So in this case, we are going to use these quadratic identities a plus b squared, which in the expanded form is a squared plus 2ab plus b squared. So in our case, what we have been given is x plus 5 squared. So in the expanded form will be what? We need to get the corresponding value. So in our case, a represents x and also b represents 5 is equivalent to 5. So this is what we are going to substitute into this expanded form of the equation. So whenever we have a, we substitute with x. So we are going to have x squared, then plus 2. Whenever we have a, substitute with x, multiply by x. Whenever we have b, substitute with 5, multiply by 5, then plus b is 5, so that will be 5 squared. So we have x squared plus 2 times 5, that is 10 times x plus 25. So that's how we use the quadratic identity to expand. Also, we can have the second example, 3 minus x squared. So in this case, we are going to use this quadratic identity. Since it is minus, so we use a minus b squared. Expanded form is a squared plus 2ab plus b squared. So in our case, we have 3 minus x squared. So this expression, they are equivalent to each other. So a corresponds to 3. So a will be equal to 3. And then minus b is equals to minus x. Therefore, in this case, b is equals to x. So we use this value and this value. So this is what we are interested with. Therefore, from here, expanded form a is 3. So that is 3 squared. Then, sorry, here it is minus. Here it is minus. So minus 2. A is 3. And b is x. Plus b is x. So that is x squared. So we end up getting 9 minus 6x plus x squared. So that is the expanded form using quadratic identity. The other example, number 3. So we have 2x plus 3 bracket 2x minus 3. So using quadratic identity, this is a plus b multiplied by a minus b, which gives a squared minus b squared. That is difference between two squares. So in our case here, we have been given 2x plus 3 multiplied by 2x minus 3. So we need to get the value of a. In this case, it will be equivalent to 2x, and b is equivalent to 3. Therefore, in our case, if we expand using quadratic identity, a is 2x, so we square it, then minus b is 3, we square it. Therefore, we end up getting 4x squared minus 9. And that is the expanded form of this expression using the third identity. Also, in a real life application, we can also be able to use some multiplication, multiplying them easily using quadratic identity. Take an example of this, and it's very interesting. Use quadratic identity to evaluate. So the first question is 104 times 96. So we need to get numbers, or we write it such that we are going to form some quadratic identities. Then we are able to solve it without using long multiplication. So 104 and 96, all of them are closest to 100, because it is very easy to multiply numbers that are multiples of 10, 100, 1000, 10,000, etc. So it is very easy to multiply such numbers. So we are going to consider 104 times 96. We see that 104 is exceeding 100 by 4. 96 is less 4. So 104 times 96 can be written the same as 100 plus 4 multiplied by 96 is the same as 100 minus 4. In this case, this leads us to the quadratic identity, that is a plus b multiplied by a minus b, which gives us a squared minus b squared. That is difference between two squares. So a in our case represents 100, so that will be 100 squared minus b is 4. In our case, b is 4, so minus 4 squared. This is 10,000 minus 4 is 16. And it is very easy to subtract this. So 10,000 minus 16, we have 4. So 9, 8, we have 9, 9. So therefore it means that 104 times 96, we end up getting 9,984. try to prove using a calculator, you should get the same answer. Let me try the last. So you can also use quadratic identity to solve this. We have 1020 multiplied by, that is 980. So the same, we can also work it out. This can be written as the same as all of them are closer nearest to 100. They are closer to 1000. So this can be written as 1000 plus 20 multiplied by the same as 1000 minus 20. So we have actually write them in this form: difference between two squares, such that a is 1000. So we have 1000 squared minus b is 20, so minus 20 squared. So this is the same as 10 100. So that's 1000. So the same as 1 million minus 400. Minus 400, we shall end up getting 36,999. So if you multiply this value, you should get 999,600. So that is the multiplication or evaluation of this sum using quadratic identities. So thank you so much.